Hello, this is Ms. McCauley, and this is part 4 of Simplifying Expressions for Common Core 7th grade. Again, Mrs. Bino will be, a former Viking teacher, will be finishing up this lesson with you.
Okay, let's try the next one. Just 2 more to do with the algebra blocks. Okay, 2x minus 4 plus 3x plus, did we do this one already? Nope, just kidding. Let's keep going. Okay, 2x minus 4 plus 3x plus 2. Step 1, you know it by now, model with the algebra blocks. Let's do that. Okay. So I'm going to start with positive 2x. 1, 2 positive x's on the positive side. Then I believe it was, minus 4. 1, 2, 3, 4 on the negative side. Then we've got 3x plus 2. So another positive 3x. Okay, plus 2 positive. So here's our original expression. Let's go ahead and take a picture. Okay, next thing we need to do, combine like blocks, or in other words, like terms. Let's see here. Well, we can definitely combine all our positive x's, right? Okay, put those together. Now let's take a look at our greens. I see some 0 pairs we can make. 1 positive, 1 negative, take it away. 1 positive, 1 negative, take it away. Okay, so here's our expression simplified. Remember, we cannot combine yellows with greens, not the same block. Okay, go ahead and take a picture. Drop that into GoodNotes. Alright, last thing we need to do, write the simplified expression with numbers. Okay? Okay, so for our x's, we've got a total of 1, 2, 3, 4, 5 positive x's shown here. Okay? So we're going to write 5x minus 2, because that 2's on the negative side. Okay? Hold on a minute here. Doesn't seem to be popping up on your screen. Make sure this is on. Let me see here. Nope. Seem to have a glitch. Alright, we're going to stop the video here and pick up with the second video with the second part of this lesson. Stay tuned. But let's remember that we were working with 2x minus 4 plus 3x plus 2. So we need to write this now simplified with numbers. So let's look at our simplified picture here. We've got a total of 1, 2, 3, 4, 5 x's, all positive, minus, we've got our 2 here. Remember, those are negative, so we want to represent that with our subtraction sign. So that whole big long expression that we started with has now been broken down to 5x minus 2. Remember, 2x and 3x are both positive, like terms, so we combine those to make 5x. Negative 4 and 2, also like terms. Combine those to get negative 2. Alright, we've got one more to do with the algebra blocks, so let's get to it. 5x plus 5 plus 9. Ooh, ended on an easy one. So let's start by representing our 5x, okay, and our positive side here, and I believe it's plus 5 plus 9. So let's go ahead and represent positive 5 with our green cubes. 1, 2, 3, 4, 5, and then also positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, since they're all positive, we're not canceling anything, we're just combining. So again, our 5x is combined, and we can combine our 5 and our 9 together. So here's our expression simplified. We're going to go ahead and take our, oops, I forgot to take a picture of it unsimplified. Sorry about that. Rewind. Okay, take a picture of it unsimplified first. Okay, unsimplified. And now go ahead and take a picture of it all combined. Okay, last thing is to write our simplified expression with numbers. So again, we've got positive 5x plus a total of 14 positive green cubes. So 5x plus 14 is our expression simplified. Again, if we go back to our original expression, 5x, nothing to combine it with, so we've got 5x. 5 and 9 combine to make positive 14. Alright, now we're going to start discussing how to simplify without having to use the algebra blocks. The algebra blocks are a great way for us to visualize what we're doing mathematically, but we want to be able to jump to the next part of this, which is being able to simplify without having to use the blocks. Because who wants to carry around algebra blocks around with them their whole life, right? Okay, so simplifying without algebra blocks. Step 1 is going to be to somehow note the like terms. So I'm going to put the color code just because I love to color code things. So color code the like terms in the expression. Anyone else out there a big color coder? If I could color code my socks for when I wear them, I would. Color coding is awesome. So color code the like terms in the expressions. In other words, we're grouping the like terms together. Step 2 is to combine the like terms. Okay? And then our final step is going to be to write the simplified expression. So those are our steps for simplifying without algebra blocks. So let's go ahead and take a look. Okay, so our first expression is 2x plus 3 plus x minus 2. So we're going to color code, so pick whatever color you like. I'm going to start with purple. And I'm going to start with my first like term here, which is 2x. Okay, so I need to find any other terms in this expression that have an x in them to the first power. Remember, think about with your algebra blocks, any blocks represented with the same kind of block. So I'm also going to color code x, okay? Those are going to be my like terms for x. Then I'm going to switch to a different color. I'm going to go with a pretty blue, okay? Now remember, 3 is a constant. It's a number that doesn't have a variable attached. Any constant should be grouped together. So I'm going to group 3 and my negative 2 together. Notice that subtraction sign needs to be applied to the 2. Okay, next step, combine like terms. 2x plus x is going to give me a total of positive 3x. 3 minus 2 is going to give me a total of positive 1. So I can say my simplified expression is 3x plus 1. Double check to make sure you've combined all like terms. Right? Let's go to the next part. Next expression we have is 2 plus 8z plus z minus 5 minus 9z. Alright, again, let's start by color coding. So I'm going to start with my 2. Since 2 is a constant, meaning no other variables are attached, I'm going to go ahead and color code any other constants I see. So negative 5 is a constant. Okay, don't see any others, so I'm going to switch colors. I'm going to go with a pink this time. Okay, 8Z. Any other Z's I see to the first power? There's another Z. And negative 9Z. Okay, I'll start by combining my Z's. 8Z plus positive Z, remember that's a 1Z. 8Z plus 1Z is 9Z. 9Z minus 9Z gives us 0Z. Okay, then 2 minus 5, or in other words, 2 plus negative 5, use that KFC. 2 plus negative 5 gets us negative 3. So I can say my final simplified expression is negative 3. I can drop that 0 off. It doesn't really mean anything. All right, let's try a couple more. So we've got 12y plus 3x plus 4x minus 2. All right, color code my 12y pink. Well, I see other variables here, but I don't see any other y's, only x's. Remember, don't combine x's with y's, not the same type of block. So, switch colors again. I'm going to highlight my 3x purple. Any other x's? Yep, we got a 4x. Okay, then I'm going to highlight my constant, which is negative 2. No other constants. Go ahead and start combining like terms. 12y is everything to combine with. 3x plus 4x is 7x. And then I'm going to end that with minus 2. So my simplified expression is 12y plus 7x minus 2. All right, let's try another one. Love all those pretty colors, by the way. Don't you just love the colors? Okay. All right, so we've got negative 7x. Don't forget that negative. Okay, look for any other x's. Negative 3x and positive 5x. Okay. Switch colors. Now we've got positive 4 as a constant. No other like terms for 4. So sad. Let's combine our like terms. Negative 7x minus 3x. I'm going to do KFC to make this easier. 7 plus negative 3x. So negative 7x plus negative 3x is negative 10x. Negative 10x plus positive 5x is negative 5x. 4 has nothing to combine with, so that's plus 4. So my simplified expression is negative 5x plus 4. Okay? All right. Now let's talk about applying expressions to real-life situations. All right. So let's say you're shopping. The cost of a jacket after a 5% markup can be represented by the expression J plus 5/100ths J. Simplify the expression. Then determine the total cost of the jacket after the markup if the original price is $35. Okay, so let's write down our expression. J plus 5/100ths J. Let's start by color coding like terms, so J. And then I do see another J here, 5/100ths J, so these are all like terms. Now remember that J at the front has an invisible 1 as a coefficient, okay? So that all together adds it. So we're doing 1 plus 5/100ths gives us 1 and 5/100ths J as our simplified expression. Now, they want us to take this one step further and determine the total cost of the jacket after the markup if the original price is $35. So we're going to plug in J, or $35 for J. Okay? So 1 and 5/100ths times 35. Okay? And you can work this out. Let's set this up. We just learned about decimals. Stack, multiply, count, and bump. Stack them against the wall. Oops, and I ran out of room. Let me move this up. Okay, if we go ahead and multiply, 5 times 5 is 25. We'll carry the 2. 5 times 0 is 0, plus 2 is 2. 5 times 1 is 5. Oops, I'm going to run out of space. You're running out of space too. Let's go ahead and we'll copy this to a new page just to make sure we've got enough room. I'm going to use my lasso tool to do that. I'm going to add a blank page below. Okay. Okay. So there it is. All right. Okay. So we've done our first row. Let's go ahead and cross out the 5, anything we carried. Remember, we need a 0 in our second row. 3 times 5 is 15. Carry the 1. 3 times 0 is 0, plus 1 is 1. 3 times 1 is 3. Okay? Add that together. 5 plus 0 is 5. 5 plus 2 is 7. 5 plus 1 is 6. 3 plus nothing is 3. If we count, we've got a total of, 2 numbers to the right of the decimal point. So we're going to bump over 1, 2 places. So we can say that the total cost of the jacket is $36.75 after the 5% markup. Okay. All right, let's try another one together. Okay, so this is at a concert. You buy some t-shirts for $12 each and the same number of CDs for $7.50 each. Write an expression in simplest form that represents the total amount. Okay, so the key word here too is that you're buying the same amount of CDs and t-shirts, so we can actually use the same variable to represent how many you buy. So we're going to let X represent the number of t-shirts or CDs you buy. Okay? Okay, so let's go ahead and write our expression. So you're buying some amount of t-shirts, they're $12 each. We don't know how many you bought, so we're going to represent that with 12x. Plus, you also bought some CDs for $7.50 each, but again, we don't know how many you bought, so that's plus $7.50 x. Okay? Okay, so to simplify this expression, go ahead and color code. And we've got all x's here, so it makes it nice and easy. We're going to combine 12x plus $7.50 x. So all we really need to do is add those together. So we can then simplify that to $19.50 x. Okay? All right. Let's try another one. This one says, Manfred buys some boxes of cereal for $4.85 each and the same number of bags of pretzels for $2.90 each. Write an expression in simplest form that represents the total amount spent. Okay, so once again, he's buying the same amount, so we're going to let X represent the amount of boxes of cereal and bags of pretzels. Okay? Cereal boxes are $4.85 each, and we're going to multiply that times X because we don't know how many he bought. Plus, okay, bags of pretzels are $2.90 each, and again, times X, we don't know how many he bought. Okay, so to simplify this color code, we've got our X's and we've got our X's. So we're going to go ahead and add those values together. So we've got $7.75 X. Okay, and that's our expression simplified. Okay, so this concludes the lesson on simplifying expressions. Make sure that you complete the note check before moving on to the next step.